Good morning, students. Am I audible?
Yes,
Yes,
sir.
sir.
Okay. So this is a class of railway engineering, professional elective one. So it will be a continuation of the previous class. That means yesterday we are discussing about different resistance, or you can say resistance force that may exert it uh, in a railway track, which try to uh, resist the movement of the train. Clear? So if you remember, there are different type of resistance or resistance force that we have to take into account when it comes to decide, or they can decide, or they regulate the movement of the train, like resistance due to friction. Did you remember? Resistance due to friction, resistance due to wave, resistance due to curvature, resistance due to super elevation. Okay, so this thing, I think, how many are there? I will show you one more thing. So resistance due to friction, yeah, resistance due to wave action, then resistance due to wind, then resistance due to gradient, not super elevation, resistance due to gradient, then resistance due to curvature, and resistance due to starting and accelerating. So these six uh, kind of resistance, um, it's under these various resistance and their evolutions topic. Fine. So in the last class we have discussed about first four type of resistance, like we have discussed resistance due to friction, then resistance due to wave action, then resistance due to wind, and resistance due to gradient. So till now, do you have any doubt regarding previous class? Till then, I will share my screen. So here you can see. So we have discussed about various resistance forces that may act in a movement of the train. So basically, it is divided in two parts actually. So first one, your uh, the resistance given by the internal or external, internal or mechanical forces between the locomotive and the wagons or the apartment. And another one is your external, that means your atmospheric resistance. Okay, atmospheric resistance, like we can consider the wind. Okay, that resistance due to wind, it's kind of an external resistance. Okay, and the point that I told you to mark, that in case of resistance due to friction, it is independent of the speed of the train. Okay, this friction, the resistance due to friction, it is independent of speed, and it is the formula here. It is only depend on the weight, that is weight of the train, which is given in tons. But when it comes to wave action, which is because of the irregularities in track profile, due to the irregularities in the track profile, somehow in some areas uh, a train may go through this resistance due to wave action, and this wave action, it's depend on uh, speed of the train. You can see it is depend on the speed of the train, as well as the weight of the train also. Okay, then here you can see the resistance due to wind. Basically the wind resistance, or the magnitude of the wind resistance, is basically depend on the shape and size of the vehicle. That means we are talking about the locomotive. as well as the wagon also, and the speed of the train, and along with that, wind direction and wind velocity. Okay, these four are very important terms that we need to taken into account, especially in case of calculating the magnitude of resistance due to wind. And here we can see I have two empirical formula. One use correlating with or taking input parameter as area, the out of the outer is surface area, you can say, of the locomotive. A is the exposed area of the vehicle, it means your locomotive, or also the wagon also. And the V is what? V is your wind velocity. Okay. And in second formula here, it is input parameter is your weight of the train in ton, and V is your velocity of train in kilometer per hour. Okay. And these things also discussed in last class. Resistance due to gradient. So in rising gradient, a train or a locomotive required extra effort. Okay, extra effort to resist the additional resisting force, and which is due to the weight, the component of wave. Okay, that is W sine theta. Okay, this is all your mathematical free body diagram. It is already discussed in last class. I think you got this thing. Okay, if you have still have doubt, you can ask me. I hope you have gone through this. I've already shared in your WhatsApp group. Next, we'll discuss about today resistance due to curvature. So I already told you there is a irregularities in track profile. That means if I give you, okay, say the track profiles are not uniform or straight. Okay, in different because of the geographical situation, due to the different irregularities in geographical situation, the track profiles are not uniform. They are in this kind of uh, manner also. They also take a curvature point. Okay. Okay. I think in transportation engineering one also you have in highway engineering you got this thing, right? A curvilinear road. I think, yeah, this is a compound curve, you can say, na, circular curve. This is transition curve. It is almost similar like that. Okay. So it has a radius also. It may be vary. It may be a constant. For circular, it is constant. For a transition curve, it may be vary the radius. I'm talking about the radius of the curve. Okay, there is some center point will be there, center. So basically this is a curve road, or you can say if we are talking about railway engineering, so it will your track, railway track, curve railway track. Okay, so now we are discussing about the resistance with which a train will experience during movement in the curve. Okay, so when a train negotiate a horizontal curve, okay, we are talking about horizontal curve. That means we are seeing the top view. I'm whatever I'm giving this horizontal curve. So this is a top view. Okay, from sky we are seeing this. So when a train negotiate a horizontal curve, extra effort is required to overcome resistance offered by curvature of track. Now, how a curvature of track can give a resistance to the movement of the train. So we're going to discuss about that. Okay. So basically, the curve resistance is caused by the following reason. Okay, the first one is very important. Okay, so the vehicle cannot adapt itself to a curved track because of its rigid wheelbase. That means, uh, like a curved wheel, train wheel cannot move in all direction. It's a rigid. Okay, it is not like it is not similar to the vehicle moving in a road. Okay, in road, whatever vehicles are moving, the wheels are free to move in any direction. But it is not the same case for the railway wheel. It is a rigid. Okay, it is only designed to move in a rigid part. Okay, or in a straight part, you can say, not straight exactly, but in a one common part. Okay, so the vehicle, sorry, the wheel of the train, a wheel of a locomotive, you can say, it is a rigid wheelbase. Okay, it's a rigid. That means this is why the frame takes up a tangential position as a vehicle tries to move in a longitudinal direction along the curve. That means I'll show you a curve. Okay, how it's look like. Can you see here? Is it visible? Okay, let me give a
Yes, sir.
bigger picture. Okay, now suppose this is a pair of a wheel, two pair of a axle, or one pair of axle, you can say. Okay, so it is a position where a train is moving along a curve. Now you can see the leading wheel axle and the trailing wheel axle. Okay, this is your leading wheel axle. Okay, leading axle, it is trailing axle. Okay, and all the wheels connected to the leading axle is called leading wheel. Okay, and here it is your trailing wheel. Fine, and B is your center distance between, or spacing between the wheel, or spacing between the axle. Sorry. Fine. So can you look closely here in the wheel position? Since wheels are rigid, they cannot adjust it themselves. Okay, they have to follow their own path. Okay, and at the peak point of the curvature, here you can see the position of the wheel. Okay, if you remember, uh, and you are seeing this is a top view, as a top view. Okay, so this part is your rim part, rim, or you can say the tread of wheel. Okay, this is your tread of wheel, and this black part. Okay, I'll show you like this. Okay, this part, I'm talking about this part. This part is your flank, right? This is a straight in a larger diameter is a flank part. Okay, this is a flank part. This is your tread of the wheel. Fine, and here there is a rail. This is your rail part. This is your rail. This is your rail. Okay, and the wheel moving along the rail. Okay, now here in this particular drawing, you can see the rim part, the flank part. Sorry, the flank part of the leading axle wheel is rubbing against the inner face of the rail. Okay, even here also you can see the flank part of the wheel of the trailing axle is rubbing along the inner face of the rail in inner circle. It is an outer circle. Okay, so it is statement is given here. The vehicle cannot adapt itself to a curved track because of its rigid wheelbase. This is why the flame this is why the frame takes up a tangential position as a vehicle tries to move to a longitudinal direction. Tangential position means with respect to this curve, this you can see these vehicles, the wheels are taking as a tangential position, not in the curved position. They are behaving like a tangent to the curve. Okay, that's why it's called a tangential position. Tangential position or tangential direction. Okay. This is why the frame takes up a tangential position as a vehicle tries to move in a longitudinal direction along the curve. Okay, but that means the wheel always try to move in a longitudinal direction, not in the curve. It is not made of to run in the curved direction. It's always, since it is a rigid wheels, it always tends to move in a longitudinal direction. Okay, if I consider the longitudinal direction here, I'll show you. If I extend this, sorry, if I extend this straight part, suppose up to this is straight, right? If I extend this, your straight part will be like this, isn't it? Suppose there is no curve. So, okay, that means your railway track is like this. It is straight. So the wheel always tends to move in the straight part. Okay, since it is rigid. But actual part is what? Actual part is it's moving in this direction. It means it take a curve linear path. Okay, but because of this curvature, uh, the wheel of the train takes a tangential position with respect to the curve. Okay, because it always seems to move in a longitudinal direction. Got it? On this account, the flank of the outer wheel of the leading axle rub against the inner face of the outer rail. That means, I'll show you here. On account of this, the flank of the outer wheel, flanks of the outer wheel of the leading axle, flank of the outer wheel of the leading axle. This is your leading axle. This is your outer wheel. Okay, and this is your inner wheel. This is your inner circle, outer circle. So this is your outer wheel, inner wheel. This one also your inner wheel. These two are outer wheel. Okay, fine. So the flank, this is a black dark color. This is a flank. Okay, the flank of the outer wheel. Okay, the flank of the outer wheel of the leading axle rub against the inner face of the outer rail. Okay, here it is a very important. Okay, the flank of the outer wheel of the leading axle rub against the inner face of the outer rail. That means it rub against the, this is your outer rail, this is your inner rail. The flank of the outer wheel of the leading axle rubs against the inner face of the outer rail. From the drawing also it is visible. Okay? And it gives rise to the resistance to the movement of the train. Okay? So similarly, at the same way, you can also say uh, the inner wheel of the trailing axle, the inner wheel of the trailing axle rub against the inner face of the inner rail. Okay, rub against the inner wheel. Okay, as this also gives resistance to the, okay, it provides some, or it creates some friction between the rail surface and the flank, and it also cause some failure of the flank part also. Okay, so this how a resistance due to curvature may generate during in curve. Okay, another some points also there. Okay, that like curve resistance can sometimes be the result of longitudinal slip, which cause the forward motion of the wheel on the track, and the outer wheel flank of the trailing axle remain clear and tends to derail. That means, okay, along with option C, the curve resistance caused when a transverse slip occurs, which increase the friction between the wheel and the flanks. Okay, I'll discuss these two together. That means there is a sense of when the train is moving along a curve, there is a sense of longitudinal slip and transverse slip. Okay, that means you know what is slip? Slip means okay, let me take it again a curve. Suppose this is your track. Okay, this is your railway line, and this is your wheel. Okay, fine. And I'm giving you that one. Suppose this is your train. This is your train. It is like a side view. Okay, this is your side view. It is side view. Now, when it comes to longitudinal slip, now this is your longitudinal direction. Longitudinal slip means the wheels are moving or rotating at the same position. It's called slipping. Okay, there is no displacement of the wheel. Okay, but wheels are moving or rotating at the same position. It's called longitudinal slip. Okay, and your transverse slip means it is moving in that direction. That means your along the or you can say outer direction, or there is a possibility of derailment of the rail. Okay, that means if a train is moving in this direction, there is a possibility of derailment. That means it is the rail or the wheels always tends to move in outer direction, right? So there is a possibility of derailment. That means the rail may move in this direction if appropriate speed is not maintained. Okay, so basically for curve resistance for different gauge, we have a different curve resistance. Okay, here this is the important part. Okay, so curve resistance for different gauge like broad gauge, meter gauge, and narrow gauge. Based based on different gauge, we have a different curve resistance that can be found out empirically. Okay, like this: 0.004 multiplied by WD. Okay, like 0.003 multiplied WD and 0.002 multiplied WD respectively for broad gauge, for meter gauge, and narrow gauge, where W is your weight of the train in ton and D is your degree of the curve. Degree of the curve means uh, this curve. I'm talking about this curve. Okay, this degree. Okay, this degree of the curve. So using this empirical formula for different uh, track gauge, we can determine the curve resistance. Okay, these things are you can also read it by yourself. Compensated gradient for curvature. So you can also minimize the curve resistance by you know reducing in the gradient. Okay, we can also using the gradient, different reduction in gradient, we can also minimize the curve resistance. Okay, you can also just read by yourself. There's some points are very important. Okay, for different broad gauge, the compensation is 0.004% can, that means super elevation on broad gauge. We are not discussing super elevation right now. Okay, in coming classes we are discussing super elevation also. That's why I'm not want to discuss right now, but for now you can take this as an important part. uh, you already have got the regarding super elevation in highway. Okay, there is one part is the outer part is little extended or rises from the general ground. That means that this is the outer part, right? What is super elevation? That means the outer rail or outer edge is raised little bit higher comparatively to the inner face. Okay, to resist the centrifugal force. This is a basic thing. I think you have got this thing in highway engineering also. Kind of same thing. Okay, so we can also maintaining or compensating or managing the super elevation or cant. We can minimize the resistance in curve. Okay, like compensation in gradient like 0.004% for broad gauge, 0.003% for meter gauge, and 0.02% for narrow gauge line. Okay, for every 1 degree curve. For every 1 degree curve, that is whatever degrees will be there for each section, we can give different compensation for super elevation or cant. Okay, so we're going to discuss uh, about super elevation in coming classes. Okay, so this is all about your curvature. It means your resistance due to curvature. Fine. Next, I think something is left. Yeah. So at the last, resistance due to starting and accelerating. That means suppose a train is in a rest position. That means in a station. Okay. At the very beginning of the start, it give a push. Okay. Even whenever you are in a train, I think you also experience a sudden push or sudden shock when it start. Okay. So at the time, this kind of a resistance, whatever the resistance occur, that particular resistance is account in this section. That is resistance due to starting. And accelerating means when it try to accelerate its speed, then also there's a resistance force also occur because of the weight only. Fine. Weight means weight of the engine or weight of the locomotive and weight of the wagons. Fine. So these are discussed in resistance due to starting and accelerating. So train faces this resistance at station when they start or accelerate or decelerate. Okay, decelerate means when it reduces the speed. So there's a two unique correlation or empirical equation for calculating the resistance at the time of starting and resistance at the time of accelerating or decelerating. Okay, so here you can see it's a very simple equation. So 0.15 into W1 plus 0.005 into W2. Here W1 is your weight of the locomotive in tons, and W2 is your weight of the trailing vehicles. Okay, that means two individual different coefficients are multiplied with weight of the locomotive and weight of the wagon when it comes to uh, determining the magnitude of resistance at the time of starting. And when it comes to find out the resistance due to accelerating, that means in a moving position and a moving condition, then we can take as a whole total weight of the um rolling stock. That means combining the weight of the locomotive and weight of the wagon. That means this W in the second equation, this W represents what? W1 plus W2. Okay, that means it is a summation of weight of the locomotive and trailing vehicle. Trailing vehicle means it may be a passenger compartment or goods wagons. Okay, and here A is your acceleration, whatever the amount of acceleration is providing. Okay, fine. So it is what how to find out the acceleration. It depend on the change in velocity with time. Okay, we can determine what is the initial velocity, what is the final velocity at different time at a particular time. So can be determined the acceleration. And this W1 and W2 are the constant term only for a particular type of engine and for a particular set of wagons. Okay, so this is about your resistance due to starting and accelerating. Clear? Is it clear till now? So we have completed this various resistance and their evaluation. So there are total 6 resistance type we have already discussed. We just go through this type. Okay, is there any doubt till now? कोई डाउट है क्या नहीं? Okay, then we'll discuss a add-on part. Okay, along with this some additional part is there, so I'm going to discuss right now a small thing, that is your hauling capacity and tractive effort. Okay, so it is related to your friction part only, that means the resistance part only. That's why I'm taking up this one. Okay, so basically hauling capacity means what? The capacity of a particular locomotive to drag the trailing wheels, trailing vehicles. Okay, okay, so you know this term that a particular rolling stock, it consists of engine part, that is your locomotive. Okay, connected by different wagon. Okay, like that. Okay, so there are some driving wheel or trailing wheel or leading wheel will be there. Okay, they are so leading wheel, they are all are sorry, trailing wheel, they all are trailing wheel. There's some are driving wheel, some leading wheel, and trailing wheel will be there. Okay, so for a particular locomotive, it has some horsepower, you can say, or power or capacity. Okay, standard capacity. That means it was pre-decided a particular engine can carry how much. That means it can drag how much load. Okay, this is your hauling capacity of particular engine. And tractive effort means what? The effort generated an individual wheel. Okay, individual wheel means to move a particular wheel what is the effort required by engine? It is your tractive effort. Okay, and it must overcome the friction between the wheel base and the rail surface. Okay, so by theory or by textbook, their definitions are there. So the tractive effort of a locomotive is the force that the locomotive can generate for hauling the load. Okay, that means hauling the load means to drag the trailing load. What is the effort a particular locomotive can give? That means the force required by a locomotive to drag a trailing load. It is your tractive effort. Okay, the tractive effort of a locomotive should be enough for it to hold a train at a maximum permissible speed. Okay, and tractive effort must be greater than what is required to hold the train, else the wheels of the locomotive may slip. Okay, we're going to discuss this term also. That means there is a sufficient amount of tractive force that required to move the train. Okay, that means if you are not giving that amount of tractive force, the train will not move. Okay, and again, if you are giving too much of tractive effort, then also the train will not move. They will go sleep in a same position. Okay, that means there is a particular definite amount of effort, that particular amount of effort that required to apply in a particular wheel or particular axle to move. Okay, that is your tractive effort. And hauling capacity is a overall the hauling capacity of a particular engine to move the train. Fine. So we're going to discuss our hauling capacity. You can also discuss about steam engine, how to find out tractive effort of steam engine. There is a formula for diesel engine and for electrical engine. Okay, I'm not going to discuss about this. Okay, so hauling capacity of the locomotive is what? The hauling power or hauling capacity of a locomotive depends upon the weight exerted on the driving wheel and the friction between the driving wheel and the rail. Okay, that means I'm going to elaborate now here. Suppose this is a, okay, wait. Okay, suppose this is your rail, okay, and this is your wheel. Okay, this is your center point of the wheel, and it gives some weight. This is your weight of the wheel acting downward. Okay, and because of the contact of the wheel tread with the surface of the rail, there is a friction force. Okay, suppose um, the train is tends to move in this direction. Train is move tends to move in this direction. Okay, so the friction force, whatever you know about friction force, right? Friction force always tends to move against the movement. It always try to resist. That means it will move in. It will tends. Suppose this is friction force. Whatever friction it will be there. Okay, friction force will be act in the opposite direction. Okay, so if you consider a single wheel, a driving wheel, a train or a locomotive required a sufficient amount of tractive effort, okay, to move this train, or sorry, to move this wheel, okay, and it must overcome the friction. It must overcome the friction, okay. That means your overall, the if I tell you the hauling capacity or hauling power of your locomotive will be equal to, if you consider only one wheel, I'm considering only one wheel, that means the W weight of the wheel multiply by the friction. Okay, this is the minimum amount of tractive effort or tractive force is required by the engine to generate to move this vehicle, minimum. Okay, and if you provide a too much of tractive effort, too much of tractive effort compared to your frictional resistance, suppose frictional resistance have some value, okay, and suppose I'm giving just for example, suppose 5 unit of frictional force is there, but if you provide 100 unit of tractive force, too much. Okay, then what will happen? The wheel will go on move or roll in the same position only. It will not move or forward. It will move in a same position. That means it will go sleep in the same position. Okay, got my point? That's why it is given here. No, if the tractive effort is much greater than it required, it greater than it required means greater than the frictional resistance, or greater than that it required to hold the train, the wheels of the locomotive slip. Slip means it will roll at the same position. Okay, okay. So holding power of a locomotive depends upon the weight exerted on driving wheels and friction between the driving wheel and the rein. That means I already told you na, the whatever holding power of a locomotive depend on the weight exerted on driving wheel. That means the you can say the dead load of the wheel, dead load of the wheel, dead load of the axle, also dead load of the total overall engine or overall train. All come in the wheel only, right? The dead weight plus multiplied by the friction between the driving wheel and the rail. Okay, the coefficient of friction depend upon the speed of the locomotive and the condition of the rail surface. Higher the speed of the locomotive, lower will be the coefficient of friction. That means if you increase the speed of the locomotive, the friction will be less. That means it will move comparatively higher. And that means you have to maintain a certain amount of speed. You cannot give it too much of speed like that. Okay, and the coefficient friction is ranges between zero point 0.1 to zero point 0.2, like 0.1 for high speed and 0.2 for low speed. Okay, and condition of rail surface, like it may be a wet, it may be dry, smooth or rough. Okay, this also play an important role. Okay, so basically if I give you a general definition for hauling power of a locomotive, it's defined by the overall weight acting on the wheel, or you can say acting on the axle multiplied by friction. Now how can you find out overall weight of acting on the wheel? Number of pair of the driving wheel multiply the weight of its driving axle and coefficient of friction. Okay, did you got this thing? If I give you a front view, suppose I'm giving a front view. So if I give a front view, this is your engine part. Okay, it's moving in this direction. Okay, it's moving in this direction. This is your railway track. Okay, this is your railway track. There is a driver moving the train in this direction. So, okay, suppose this is your train is moving in this direction. Suppose, imagine. Okay, now here you can see the axle. One each axle connected with two wheels. Okay, fine. So number of pair of driving wheel. How many pair of driving wheels are connected here? We need to first count. Okay, suppose in the particular problem it is given two numbers of uh, wheels pair is given. So we have to give this, suppose this one pair, this second pair. Suppose there is a third one, a third pair, like that. Okay, first we have to find out how many pair of wheel axles are there in particular engine, okay, or particular train. Then multiply the weight exerted on each axle. That means suppose particular for each axle, that means for overall this we have particular given W weight. That means then multiply the its weight exerted on its axle, then multiply the friction. Somehow individual load or individual weight of wheel also can also be given. Okay, then how to do? Okay, this there is a problem. You can from this also you can also understand. So for suppose for a locomotive with three pair of driving wheel, an axle load of 20 tons are given. Okay, and coefficient friction is 0.2. That means if I can draw again, uh, suppose this is your train, okay, railway track. There is suppose this is your train. This is your train, okay? This is your train. This is your pilot, okay? Here in the front wheel, you can see, suppose 1 and 2, okay? Now, I think you have to visualize this, okay? So this is your train. So for now, I'm showing only 3 pair of uh, axle or 3 pair of wheel in a particular locomotive. Okay, this is a 1 pair, second pair. Okay, one wheel or wheels will be in this direction, and this third pair. So as per this problem, suppose for a particular locomotive, 3 pair of driving wheels are there. That means this is one wheel, second wheel, and third wheel. Third means third axle. Okay, first axle, first, second, third axle. Okay, that means 3 pair of driving wheel, 1 pair, second pair, and third pair of the wheel, and axle load of 20. That means for this first pair, load is how much? 20 ton, and the coefficient friction is equal to 0.2. The hauling power will be how much? 3. That means 3 pairs are given, right? The 3 multiply that load for each axle, multiply the friction. You will get a 12 ton. 12 ton will be your hauling power for particular locomotive. Okay, suppose in particular exam, if I give you like in place of axle, is given as a wheel load. Okay, in place of wheel load, in place of axle, it's suppose it's given as wheel load. Okay, then that means wheel load means an individual wheel load is given. Okay, then it will be different. Suppose 3 pair of driving wheels are given, so it will be 3 pair. 3 pair means how many wheels are there? For each pair 2, that means 6 wheels are given. That means 6 wheels are given. Now if wheel load is given, that means wheel load is how much? Say 20 multiply 0.2, sorry, 0.2. So we have to, it will be now 2 times increase. That means it will be 24 times for the same problem. Okay, got it? So you have to concentrate whether it is axle load is given or wheel load is given. Clear? Am I clear? Okay, this is all about today class. Okay, so I'm going. Is there any doubt till now? If you don't have any doubt, then I'm just closing my recording. It is all over 40 minutes now.
Sir,
Yeah.
locomotive is a Luby, right, sir?
What? No, no.
Locomotive
लोकोमोटिव है तो इंजन पार्ट, ठीक है, द
or
फ्रंट
engine
पार्ट
part?
तो
Okay.
खींचता है ट्रेन को, ठीक है। और बाकी जो
हाँ हाँ
एडिशनल होता है ना बोगी, दे आर कॉल्ड वैगन। ओके,
हाँ हाँ।
इट मे बी योर पैसेंजर,
ओके
पैसेंजर वैगन होगा या फिर तुम्हारा वुड्स कैरिंग वैगन भी हो सकता है, ठीक है। ओके
हाँ हाँ
एवरीवन, you have to rejoin the meeting, okay, because the meeting time will be over within a minute. Clear? So I'm stopping my recording. I'm stopping my recording and I'll take your attendance right now.